Light. This is going to be a short video on using SPSS to create descriptive statistics. And so these would be basic summary statistics that are used after you've prepared your data. You're going to run some analysis, describe the variables based on the responses that you received. So these will be summary descriptive statistics. They'll be associated with things like occurrence, mean or average, standard central tendency. There'll be distributions like standard deviations and ranges, and we might also look at some graphing as well as some statistics that are associated with distributions as well. So that's kind of what it is. We're going to use again SPSS because SPSS is a very common statistical program used by a lot of companies. Some companies also would use R or maybe SAS. Some might use some advanced applications of Excel as well, but SPSS is very common, so this would be, and it's very user-friendly as well, which is helpful. Okay, so walking through some of this, I'm going to just walk through some examples, and you can grab some data yourselves and follow these examples as well to get the data that you want, or the results that you need. So let's look at first at counts and frequencies. This would be done with nominal or ordinal variables usually. So in SPSS, once again you have your data into the program, you've done the data preparation stage, so now you're ready to analyze. Go to SPSS, and under the data section there's a ribbon, and if you click analyze, then a drop down menu will appear. And that drop-down menu will have descriptive statistics, which you click on, and then another drop-down menu appears, which where you choose frequencies. Now, once you do this, you're going to see a pop-up menu that emerges, that develops or appears or whatever. Pop-up menu or dialog box is one where you add information, and then you ask the software to execute. So in this case, we have a variable called class. This variable is associated with a student's academic class, like freshman, sophomore, junior, and so forth. This is, again, it's either nominal or ordinal. It's going to go in here, and you just select it from the list of variables that you have in your data. And then you can choose some of the other options on the side, where it says statistics and charts and format, or you can just simply click OK. And then once you do that, then you're going to get an output from SPSS. It'll be a separate window that appears, and this is the data results. We asked for frequency, and so you can see that by freshman, sophomore, junior, senior, and graduate students, we have a count. So there are 14 freshmen, 16 sophomores, 58 juniors, 81 seniors, and 4 graduate students who completed this question. We also have the percentage of those respondents by each group as well. Percentage, of course, is easy to calculate. You can do it yourself, but this is provided for us. So this is an easy way, again, just a few clicks, and we have a summary statistic of how many of our respondents each fall into these classes. Okay, moving forward, means and standard deviations. Okay, so again, SPSS, we have this ribbon. We're going to do some of the same steps where we click analyze and then descriptive. This time, however, we're going to, instead of frequencies, we're going to click descriptives. Okay, so this is just a slightly different dialog box that's going to pop up. You'll see as it does, it's not going to look much different than what we just saw for frequencies. There'll be a few less items on the left or right-hand side of the box where it says options or style and such. Importantly here, though, the data that you want to bring over into the variable group has to be a scale variable. Okay, so again, SAT, SAT1, it has a little scale next to it. It's a Likert scale, and that's appropriate for this type of data. So it can't be nominal, it can't be ordinal. You don't want it to be. You can't do that. You can't take an average of those types of data. So it doesn't make sense. So we would not put class, for instance, in here because it's not a scale variable. Okay, so put in a scale variable. Again, like before, you can put in several if you want to do several all at once. It's not a problem. I could put all kinds of, these scale variables in there and click OK, and I would get this type of a box. Now, we only asked for one variable, SAT1. So we got SAT1. This is a satisfaction measure. Again, it was on a Likert scale of 1 to 5, so you're going to see three things here. You're going to see the range. So that would be helpful if our data was dispersed, like age or income or something like that. You'll see the mean, 3.9017. So that's the average score of the 173 respondents on this question. And we look at a standard deviation. Again, that's the spread. That's a pretty typical, somewhere around 1 is usually what you want to see. Not necessarily, it just depends on what the scale is, I guess. But anyways, that's the spread of the data in numbers. Okay, so mean is what we look at the most. That's going to be something that we would look at. You could split up your data and compare the mean across different classes or gender or whatever if you have different groups. But to get the mean of the data, the total data set, this is how we do it, okay? All right, moving forward, putting together a graph. Sometimes we have a distribution and we want to look at graphing options, or we have different groups. We want to compare results, we want to graph, we want to do a line graph, we want to do a histogram. There's lots of reasons why we might want to do a graph, okay? So here in SPSS, again, we're going to do, on the top ribbon, instead of analyze, we're going to do graphs this time. And so I'll click that. Now, what's going to happen is there'll be a little drop box. And in that drop box, there's going to be an option to do chart builder. I don't have an image for that, but the next, as you click graphs, it's going to say chart builder, and that's what you want to click on, chart builder. Right? So once you do that, we'll have chart builder up, and this is what pulls up. Okay, so this is like a different look, totally. And there's going to be 2 or 3 different things you're probably going to look at right away. One is down below, you're going to look at where it says histogram, bar chart, line charts, area charts, right? So what you want to do is you want to click on the type of chart you would like to display. Now, what I've done is I've clicked on histogram because that's the type of chart that I'm looking to do. Okay, so there's a histogram, and up above, it'll give you the histogram kind of schematic. So where it says simple histogram of age, that would be the second place that you want to look. Okay, so the first thing you want to do is you want to look at that drop box down below where you can choose the typograph. Typograph first, and once you choose the typograph, then you choose your variables that you're going to put into your graph. Okay, so in this particular case, I chose age. So from the list of variables, I chose age to put over there. I don't need to put any others because I'm not doing like a 2x2 thing. I'm not doing a line chart. I'm not comparing 2 variables. All I have is one. In a histogram, all you're doing is looking at one variable and how that variable is dispersed or spread out. So I'll click I'll put age over there, and there'll be a little button down below where you can click OK. So you click OK, and you'll run through this. You'll get your data. Okay, this will be, again, it'll come up in an image. This is the data. So you think of age as being something where it's spread out. Again, we have a mean of 22. For age, we have a standard deviation of 1.89. So we have a little bit more of a spread. But now this is interesting because age can range, obviously, from very young to very old. So when you think about a range, it's very large. However, the standard deviation is less than 2, so that's pretty tight. And then we look at the picture here, the actual histogram, and we see that there's a big group of respondents that's hovering around 22, not a lot of deviation. And then we have a few that seem like they're just outliers, like they're outside of the expectation. We have some in the 30s, and they just seem out of place. So remember back, we just looked at the spread of data from freshman to sophomore, junior, senior, and grad. We had 4 grad students, and those grad students are probably those older students, and we had a lot of seniors, like 81 seniors, and they'd all be like around 21, 22 years old. So that kind of makes sense that a big bulk of our data were from seniors, and that there's a very strong age component associated with that. Okay, so this is a histogram then. This is one way to describe this. This is also, we could look at this and say, hey, look, is this data normally distributed? So this is another thing, because we have a distribution, we can kind of extend this a little bit and see if this is a normally distributed type of a thing. Okay, so for that, we're going to go to Analyze. So look at the strip again, go to Analyze, go to Descriptive Statistics. So you've done that once before. This time, though, go to Explore. Instead of frequencies, instead of descriptives, go to Explore, right, under this tab. And what we're going to get is another dialog box. This one's going to have a little bit more in it, though. So you're going to have some options on the side, statistics, plots, options, those types of things that are going to be there. You could also add a nominal variable under the factor space. But what we want to do is, again, we're going to want to move over a scaled variable into, in this time it's called the dependent list. Okay, dependent list. Okay. Under display, you can do statistics or plots. The default is for it to be under both, so that's fine. That's not a problem for it to do that. And then once you're set, you can do OK. Now again, I'd encourage you to play around with opening up statistics and plots and options and seeing what's there, and just kind of playing around with what you get when you ask for the software to do other things. There'll be a number of different things you can do. This just literally scratches the surface. Okay, so Analyze, Descriptive Statistics, Explore, specify your variables, like in this case we have age, and then click OK. All right, so we pull this up. We're going to have a couple things so this will be the first thing we look at, the first box we look at, I guess, and then we'll look at a plot real quick before we wrap it all up. Age, we have our mean, we know it's 22. We have the standard deviation, which is in there as well. Standard deviation, that arrow will pop up in a second, but we know it's 1.89. But we also have measures for skewness and for kurtosis. Both of these are above 0. They're both positive, so that means it's going to be positively skewed. When we say it's positively skewed, it means the tail runs to the positive side. So the peak will be on the left side and the tail will run the right side. That's what's positively skewed. It's above 0, 3.6. It's above 0, so it's going to be positively skewed. It's also going to be very peaked because kurtosis is 22, again, well above 0. So it's going to be a very peaked, skewed distribution. Okay, that could be problematic. That means it's not normally distributed. Okay, so we may actually have to do some things to deal with that. Okay, also with this data, we're going to have a printout or some plots that are available too. One of the plots that you'll get is called a box and whisker plot. So if you look down your data set or the report, data report, you'll see a box and whisker plot. So the box is where the mean is. It's also got a confidence interval of data. So like that blue box rectangle that's displayed, it's kind of the space where we would expect responses. What we're also offered, though, are specific responses that fall outside of that range. So what that would suggest is that those respondents, and if you see here, there's 2, 4, there's about 6 or 7 or so that fall outside of this response box. Those you might consider outliers. And if you took those outliers out of your data set, then you're probably going to fix your skewness. You might also fix your kurtosis, although it's probably always going to be peaked, but your skewness will definitely be improved. It also indicates that 25 is the upper limit. So like anybody over 25 seems outside of the norm, is basically the way you can interpret this. Okay, so this is very helpful. It tells us about this distribution. It tells us if there's things that are wrong with the distribution that look odd. If you are expecting a normal distribution, what might be off or wrong about it. And it also indicates which respondents are causing it to be off a little bit. Okay, so SPSS, again, we looked at this idea of a histogram. We looked at this already. We looked at this data, the kurtosis, the skewness, the mean, standard deviation. Again, we have this box, but what we really want to, just kind of going back to this histogram one more time, is just to simply look at this idea of outliers. And we said there might be something odd about, those are probably the graduate students. So it may make sense in this research to drop, because there are only like 4 or 5 or something. So it might make sense to drop the grad students because they don't really, they don't meet the characteristics. They're not typical of the characteristics of the rest of the data set. Okay, so the box and whiskers plot again kind of helps us identify where these might occur. The peakedness refers again to that kurtosis bit. You see that one big peak. Another thing we could do is we could manage our data better so we don't have as many seniors, and that would probably spread this out, and it would probably eliminate some of the peakedness. Remember, 81 of our respondents, so practically half of our respondents are seniors, and they're all going to fall within the same age, basically. So we can kind of see how that might be problematic if we want our data to represent all college students. That would certainly be a problem. Okay, so these are descriptive statistics, and this is some of the analysis that we want to do in SPSS. It's just an illustration of how the software can help us. You can do these steps with all the variables that you have in your data set, and you should do that. You should do that as a process of understanding and learning your data. Okay, all right. So good luck using SPSS. Once you get into it, it's actually really user-friendly and a lot of fun. So have fun with your data.